Okay, 677 here. And what we're looking to find here are the reactions at all the supports. So we have this kind of uh, diagram here that has kind of two pieces to it. Has this horizontal piece that's pinned at E and has a support at D. And there's a pin that interlocks in between this kind of moving arm here and this horizontal piece. And we're looking for the reactions at A, so AY, AX, DY. It's not going to have an X component because it's on a roller, and the pin at E, which will have EY and EX here. All right, so the first thing we need to do is break this thing apart into two pieces. All right, so I've broken this piece into, so we have kind of this, the member at the bottom and the member at the top. And let's work on these individually. Notice that the slot here, right, there's a pin there. The pin's force here has to be directly perpendicular to the edge of this member here. It will not support a force in the kind of direction along the length of this because it's slotted. If there was a force there, it would just move up and down that slot. So the force here must be perpendicular to the slot. Okay, so I've broken this apart, and the force here on the pin there, or the pin's force here that's acting on this member and the force on the pin. If we add these two pieces back together, these forces should cancel each other, all right? Because they're internal forces, they're not external. So these should cancel each other, and that's why I drew these in opposite directions. So if you add this one to this one, they should cancel. Okay, so let's first work on this diagram here. And what we want to do is maybe just do the moments around A. All right, moments around A and set those equal to 0. And what that does is eliminates AY and AX from the equation because they go through A at the bottom here. And then we just have kind of these two things that we need to account for. So if we're calling counterclockwise positive, we have NC times the distance that it is away, and that's 5. And then we have this moment of 600 foot-pounds acting in the opposite direction. So that's minus 600, and that is equal to 0. So solving for this, we have NC is equal to 120 pounds. Okay, and from there we can just move on with our equations. We can take the sum of the forces in the x direction and set those equal to 0. And if we're summing forces, we don't need to take into account this moment. So we have AX in the positive direction here. And then we have a component of NC. So we'll have negative NC, and the component of that, this triangle, since it's perpendicular, right? This is a 3, 4, 5 triangle. So then this triangle, if it's perpendicular, it's 4, 3, 5 here. So NC in the horizontal is 4 over 5, and that is equal to 0. So we can sub 120 back into this equation here, and then we come up with AX is equal to 96 pounds. And that is one of our answers, so we'll circle that. All right, and then we'll sum the forces in the y direction and set those equal to 0. So we have AY positive up there, and then we have the component of NC, which will be positive NC, and then we have 3 over 5, and that will be equal to 0. And then AY is then 72 pounds, and that's another one of our answers. Okay, so we've solved for the reactions that are acting on this member here. We can move to the next member. And we figured out that NC is 120 pounds. Okay, so let's do the equations for this. It looks like there's two unknowns here at E, so maybe the easiest to start out with is taking the sum of the moments around E and setting those equal to 0. All right, so the 500 pounds, that will create a counterclockwise moment, so that will be positive, so we have 500. And the distance it's acting away is 2 plus 3 plus 3, that's 8. We have NC, but just a component of NC. And the downward kind of component here will create a counterclockwise moment. So we have NC, and then the fraction of that is 3 over 5, the vertical. And then the perpendicular distance is 2 plus 3, which is 5. And then we have dy, which is going to create a clockwise moment. So that's going to be a negative moment, and it's acting 2 feet away. And set that equal to 0. We know that this is equal to 120 here. And then we can solve for dy, which is 2,180 pounds, which is 2.18 kip. That's another one of our answers. All right, and from here we can sum the forces in the x direction and set those equal to 0. So what we'll have in the x direction, we have Ex, and then we also have a component of NC, which is going to be positive, so NC, and the horizontal component is 4 over 5. And that is it. Set that equal to 0. And we have Ex is equal to Ex is equal to, let's see, where is that? Negative 96 pounds. I think I got a sign wrong somewhere up here. So let's go back up. I think AY here, if NC is positive here, AY needs to be negative. So let's negative 72. So negative 72. AX is still correct, but this is negative 72 pounds. Okay, that makes more sense to me. And then we have the sum of the forces in the y direction and set those equal to 0. We have EY, and then we have plus DY, and then we have a component of NC, here, component of NC, which is then 3 over 5, and let's see, NC, EY, and then with the 500 pounds with negative 500 here, and that should be equal to 0. And EY then comes out to be negative 1,610 pounds, which is negative 1.61 kip. And those are the 5 reaction forces that the problem is looking for, and that is problem 677.